Welcome to lesson 3.2, the Side-Splitter Theorem. And in this lesson, we're going to learn something that's going to be really helpful. How to deal with triangles that overlap, like so. Okay? What are we going to do when we have similar triangles that overlap like our friends Mr. ADE and AC and B? All right? Ooh, overlapping triangles. You see we got our small guy right here, and we got our big guy right here. All right, and we're going to learn how to deal with that situation. So yeah, let me show you what up. Let me show you what is up. Now, the first thing we're going to learn is a little trick called the Side-Splitter Theorem. All right? The Side-Splitter Theorem is going to be so helpful for you. Okay, it's going to just save you a lot of time and a lot of problems. So let me just hook you up with some knowledge right now. This is the fact about the Side-Splitter Theorem right here. All right, I hope you're copying this. All right, a parallel line through a triangle splits the side of a triangle into proportional pieces. Now, I know what you're saying, like, what the hell does that mean? Let me show you visually. If I have a line such as DE that is parallel to its base, CB, so we have these two lines that are parallel, then we know the sides opposite each other are parallel, so are proportional. So I would know that AD, which is right over here, is proportional to AE, all right? And we also know DC is proportional to EB, all right? These two ratios, the ratios of the sides across from each other, become proportional if those lines are parallel. Now, once again, you might be saying, like, what? What the hell is this guy talking about? We'll do an actual example, and you'll see what I'm talking about. Right now, all you need to know is that you can only use the Side-Splitter Theorem when a line that goes through the triangle is parallel to the base. All right, so the lines here have to be parallel. That's the first condition to use this property. And the given side lengths are across from each other. So they have to look like this. They have to be across, like so. All right, so if you have those two conditions, the numbers are across from each other, and the line going through it is parallel to the base, then you can use the Side-Splitter Theorem. This might not make sense yet. Let me show you how it's done, though, and how it's going to make your life a little easier. We're going to try two examples here. In triangle PQT, with RS parallel to PT is shown below. Okay, so we have our triangle, and we know RS is parallel to PT. What is the length of RP? All right, and that's right here. We're looking for the length of RP. Well, get this. Since this meets both our conditions, one, we have our parallel bases, right? This line is parallel to the base, and on top of that, our numbers are across from each other. To solve for RP, all you do is have to set up the following proportion. Ready? 4 is to 8. Those are the numbers across from each other, as 5 is to x. All right? See how easy that was? To solve for RP, all we had to do was just do it across like that. So now we cross multiply. 4x is equal to 40. And then we divide both of these by 4. And we get x is equal to 10. All right, so RP equals 10. That was so easy because we could just go across from each other. All right, let's try another one using the Side-Splitter Theorem. All right, and we'll see once again how easy this makes our lives. In the diagram below of triangle ABC, we know ED is parallel to BC. So once again, we know our bases is parallel to this line going through it. Okay? AE is equal to 14, so I'm filling that in. AC, which is the whole thing, is equal to 21. 21. And BD is equal to 6. Find the length of AD. So since we're looking for AD, we're going to put an X at AD. Now, check it out. All we have to do is first check that our bases are parallel. So the base is parallel to the line going through. That's condition number 1, check. And the numbers are across from each other. But the problem is, before we can start this, is that we're missing this number right here. We know the whole thing is 21, right? But but we don't know what this piece EC is. Well, what you could do to find that out is just subtract 21, which is the whole thing, from 14. And that would just give you 7. So now we have everything being across from each other, and we could set up our proportions. So we could set up 14 is to x, right? These are the numbers across from each other, is equal to 7 is to 6. We get 7x is equal to 84. Divide both sides by 7. X is equal to 12. So final answer here, AD is equal to 12. And that is the side-splitter theorem. So the big key thing here that you should be taking away from this is that the side-splitter theorem will make your life very easy. If the numbers are across from each other and the two bases are parallel, you can use this nifty little trick. Now, if you don't like that trick, here's another way of doing things. And this is a really great way of handling two triangles that overlap. So let's talk about these three problems. The first one says in triangles XWV, all right, that's our first triangle, and XYZ, which is this bigger triangle right here, are similar. So we have a small triangle and a big triangle. So we got the big one in red, all right, and we got our smaller one in blue, right? And they are overlapping. Now it tells us that XW is equal to 4, WY is equal to 8, and WV is equal to 5. Find the length of YZ. Now, two things. Does this tell us that the bases are parallel? No. And does it tell us that these numbers, and are these numbers across from each other? No, right? They're not across. There should be a number here and here. So since they're not across and doesn't say they're parallel, we cannot use the side-splitter theorem. So what you need to do is this, and I'm going to scream this in class a lot. You're going to have to separate the triangles. When the two triangles overlap, you separate them. So you're going to draw your big one, and you're going to draw your small one. Okay? And these two triangles are similar as stated. And once you separate them, it makes it much easier. So the big triangle, sorry, let's start with our small triangle. Our small triangle has these lengths, 4 and 5. So we're just going to put 4 here and 5 here. The big triangle, we know the bottom, YZ, has X. And this whole side right here is not just 8, it's actually 12, because you got to add them together. Now that we've separated the two triangles, and it's so important that you draw these two different triangles right here, you're going to set up your proportion. We know that 12 is to 4 as X is to 5. So we get, when we cross multiply, we get 60 is equal to 4X. 15 is what X equals. So YZ is equal to 15. Okay? And that becomes so much easier when you just separate your two triangles. We're going to keep trying this, okay? So for this one, it tells us triangle ACD is similar to ABD. So we have our small triangle, ABE, which is right over here. This is our small triangle, and we got our big triangle, which is ACD, all right? And they're overlapping each other. So we're going to write big triangle, and you should follow these same exact steps, and you got your small triangle, okay? We're going to draw them. Now, we know that DC is equal to 24. We know that EB is equal to 8. And we know that AB is 5. We want to find the length of, that should say AC. All right, and I'm sure it says it on your paper. So what we do, we're going to just draw our two triangles, all right? In our small triangle, what we have is this. We have 5 on the side, right? That's our AB, and 8. And now we have our big triangle. Sorry, that's a bad picture. I don't even like that picture. Let's draw a more accurate picture. We have 8 and we have 5. And then we have our bigger triangle, like so. And we have 24. And since we're looking for AC, that's our X. Now we just set up our proportion. 24 is to 8 as X is to 5. When we go 24 times 5, we should get 120, which is equal to 8x. Divide both sides by 8. And we get, let's see, that's 14 is equal to x. So BC equals 14. Dope. Yeah, and that's it. Let's do one more problem just to make sure we got it, right? And I suggest just pause the video, trying yourself, but let's try it anyway. So we have our smaller triangle, MNO, right? That's our small triangle. All right, we got small triangle. Just drawing a rough sketch of it. And we get our big triangle, MYZ. And it tells us that these two are parallel, big triangle. Sorry, they say they're similar. Okay, so we got our two triangles, big and small. MN is 5, NO is 10, YZ is 14. We want to find out what YN is. So I'll show you how you do it. So we're going to fill in our small triangle, which is 5 and 10, right? Those are the two side lengths of our small triangle. In our big triangle, we have 14. And for this whole side, what we're going to write is x plus 5. You just add them together. All right, that's x plus 5. So now what you do is you just set up your proportion. X plus 5 is to 5 as 14 is to 10. All right. Now we cross multiply, and what we get is 10 times x plus 5 equals 5 times 14 is 70. Now we distribute. We have 10x plus 50 is equal to 70. Subtract 50 from both sides. We got 10x is equal to 20. X equals 2. All right. So YN is equal to 2. Got it? All right, guys, that's it. Remember, the big thing for this lesson is draw two triangles. Or use the side-splitter theorem where you can. Just know that the line going through has to be parallel to the base, and the numbers have to be across from each other. Biggity boom.